Let's talk about quantum dot solar cells. Before discussing quantum dot solar cell, let's briefly talk about quantum dots. As I have talked about quantum dots, that there are a lot of applications of quantum dots in solar cell, LED laser, and photocatalysis, TVs and display. So in this video, I'm going to talk about the applications of quantum dots and solar cell. Basically, we have a lot of solar cells in the market, silicon first generation, the second generation thin film solar cell, and the third generation, which is based on perovskite and dye sensitized in quantum dots and polymers. But what is the basic concept about bringing these quantum dots and perovskite into solar cell technology? The whole game is basically to push the energy conversion efficiency higher and higher while decreasing the cost of the materials. There are only two things. The first thing is, for example, the sunlight is coming from the sun, and we want to convert as much as light possible into energy. In simple words, we need here a material when the sunlight shine here, so we create electron and holes. So when we create, then we put here some stuff in order to collect these electron and holes. When we separate these electron and holes, then we get electricity, we get current, right? So we need a material to convert as much as light. So that is basically the conversion efficiency. And secondly, we need materials here to fabricate a device. So we need cheaper material. So the two things here, and there is a great competitions. So the nanotechnology, the concept in solar cell is basically to improve, enhance energy conversion efficiency to higher and higher, and decrease the cost of the materials, right? Basically, quantum dots and dye sensitized solar cell are perovskite basically the same, but here this is ITO or FTO, and here we use electron transport medium, and here we just use quantum dots. In perovskite solar cell, we here use perovskite, and dye sensitized we use here dye. Here is the quantum dots. These quantum dots can be any type, right? It can be from perovskite, and it can be from metal oxide, titanium, zinc oxide. Here just we put whole transport medium, and at the top we use just aluminum or silver or just gold or whatever, right? Aluminum or Ag, right? This is basically, now the whole game is basically here in this photo absorbing material. Now we need a material here, the red one, to absorb as much as light possible, right? You see here a material that absorbs photons. That means a semiconductor with high electron mobility, right? If we have more electron here and more holes we create, so the hole will go this way and the electron will come this way, and we will have large number of current, right? In quantum dot solar cell, basically we are employing quantum dots. As I explained, we just use quantum dot is a light harvesting material. We just give the chance to light to come and fight with us, so that that fighting will create some electron and photons. Quantum dot is going to replace basically bulk materials such as silicon, cadmium telluride, and this kind of solar cell technology, which is based on silicon, cadmium telluride, copper, indium, gallium cyanide. These are bulk type of material, and it's going to replace the quantum dot solar cell is going to replace these kind of technology. Why? Let me answer this question. Because we know quantum dots have tunable band gaps, as we explained. If we decrease the size of the quantum dot or we increase the size, then we change the band gap. When we change the band gap, then we change the optical property. You see here, so when we change the optical property, this means that we tune the solar light. Mean we can maximize the absorbance of solar light, because we are playing with the optical property of the material, right? If you look into the silicon based solar cell, so the highest efficiency, the theoretical efficiency is between 30 and 33%. Now if we use tandem solar cell, in why we use perovskite, the quantum dot is a tandem solar cell, because it has a tunable band gap. So for 2 layer the efficiency can go to 44, for 3 layer the efficiency can go to this much, for infinite layer cells the efficiency can go to this much, you see here. So we cannot get 100% efficiency because there are some thermal losses, etc. Right? So here for 2 layer we need this band gap material, you see here. So quantum dots can do this. For 3 layer we need such kind of material here, you see here, because we can tune the band gap, right? There are some advantages of quantum dot solar cell, which is a light harvester. The first one is, as we explained, that size-based quantum confinement enable us to tune the band gap, and thereby we improve the optical. Here you see we can use different type of band gaps. So this is we tune the band gap of the material, right? So the quantum dot is this kind of benefits. And we also explained that there is multiple exciton generation. This means that with the help of one radiations we can create hard carriers, and that is called multiple electron hole pairs. So generally when we shine the light, it escape electron, so we have hole here and electron go there, and we just make exciton, right? But with the help of quantum dots we can create multiple excitons, right? There is one drawback in solar cell, that is basically the recombinations. And the recombination mean when we dissociate these electron and holes, it again recombine, and this phenomena is unwanted phenomena in any kind of solar cells. So this is the drawback in quantum dot solar cell. Quantum dot solar cell is a growing field, and I am going to just show you how it is a growing field. If you go into Scopus and just give this quantum dot solar cell keyword and just search, let's see if my net is working. So let it comes, and I will show you here that look, this quantum dots here, with the help of this quantum dots the efficiency is this much, you see here. And if you look into this all inorganic quantum dot, this is the cesium lead triiodide quantum dot solar cell with the efficiency over 16% vitamin control. This means that the efficiency is very high here, 16% efficiency is already achieved, right? Now look, the Scopus come here. So the total documents is 7069 here, and it's a growing field. You can see here how it is the growing field. In 2021 this much number of documents is found from quantum dot solar cell. And if you look into this, you see here it's published in Nature Communications in 2021, and flexible and efficient perovskite quantum dot solar cell by Hubbard interferential. So I mean quantum dot is a very hot field in quantum dot solar cell is very hot field in there is a tremendous opportunity to go and work in quantum dot solar cell.